Good afternoon, sir. Myself, Shashidhar Maligireddy, and my registration number is 19BCE1646. So, for my digital assignment one, I've chosen the topic as Ethereum. So, normally, the overview of what I'm going to explain is the overview is Ethereum basics and what is the app deployment and connections, how it's going to be, and the blockchain, how the blockchain is included in the Ethereum, and how the transactions will be done in the Ethereum. And how the core stories are useful to it, and then the history of Ethereum. The Russian Canadian programmer, it's co-founded Ethereum when he was in just 19 years old. Because 19 years old, the history of Ethereum timeline. The first idea of Ethereum was born in the year of 2013 October month, and the crowdfunding was done in the July of 2014, and Ethereum Foundation started in that September 2014. The first release of Ethereum was done in the June 2015, and the official release is done in the 2016 March. This is the history of Ethereum timeline, as you can see on the screen. Some important concepts regarding the Ethereum or some other crypto coins are cryptography, blockchain, and smart contracts. The cryptography in the Ethereum is similar to Bitcoin. In the blockchain, it has two types of accounts and wallets, like transactions, smart contracts like Solidity, language use. I mean, Solidity means like a language used for the smart contract development. In cryptography, we have four parts like hash functions, symmetric cryptography, asymmetric cryptography, and signatures. Normally, digital signatures are used to sign the document, sign a message in the digital way. Uh, Here we use cryptographic method, ECDSA, as same what we use in the Bitcoin. Normally, so signers use their private key to generate a signed message, and the signed message can be verified by public using the signer's public key. Anyone can verify the message using the sign who has the signer's public key, whether the message is true or not. Hashes are signed in Ethereum, not in the data itself. Hashes are signed separately in the Ethereum. Hash functions. Normally, BTC uses SHA-256, but in the Ethereum, it uses KAG 256. It's similar to the SHA-3 variant. It's a previous variant of SHA-256. It's similar to KAG 256. It's similar to SHA-3. It won the contest for security in 2007, used for all hashing in the Ethereum, or the KAG 256 is used for all hashing in Ethereum. Derived differently than differently other than the standard block cipher hashes or the previous SHA functions. Blockchain, right? The blockchain, it uses a fully distributed database like a BTC. The Ethereum is a fully distributed database like BTC. The advantages of fully distributed databases are like it's highly secure, transparent, and immutable. But there are disadvantages also like scaling and performance. Due to distributed, the scaling will be more, and the consumption of energy is very more. So performance also decreases, and there is a big network. Ethereum blockchain. Blocks consists of three elements in Ethereum, like a transaction list, block header, and Umber list. In transaction list, all the transactions were included in the block. In the block header, there will be a group of 15 elements, and the Umber list of all uncle blocks included. It will be described later what is the Umber list. Now we can see what is Umbers and uncles. Some valid block solutions don't make chain. Yeah. So any broadcast block up to six previous blocks with a valid POV difficulty can be included as an uncle. So maximum 2 can be included per block. So uncle block transactions are not included just in a header. So aim to decrease the centralization and reward work. So here uncle headers can be included in the main block for 1/32 of the main blockers minus rewards given to the said miner. So you can see a calculation like example like 1 3 1333 plus Ethereum blocks. All blocks visible in the Ethereum, all blocks are visible like BTC. However, blocks have a different structure as compared to the BTC. Ethereum blockchain. Yeah. Here in the Ethereum, blocks are faster than the BTC, and the reverse is different as compared to BTC. Here, for every 12 seconds, 5 Ethereum main reward is given to the miner. Miners can make a bit more by including the uncle blocks. Like normally, miners will get a reward as they're mining. Then they want to get a more, so nowadays they are including the uncle blocks to them. So they'll get 1/32 part of the Ethereum max up to each up to 2 Ethereum. So by including the uncle blocks, now blocks are faster than easy and reward is different. Yeah, is it a heading? By using the ETH hash mining algorithm, it's a different from a bit different from totally different from Bitcoin. Helps initiate effect and GPU advantages. Involves smart contract extinction. Difficulty is adjusted in every block. The difficulty is adjusted every block in every block, but not every 2 weeks like in the Bitcoin. It has a specific time. This is an important identifier for the block. For block, the key differences are blocks keep track of balances, like the transaction balances, like a daily key sheet. It's like how much of amount is spent. I mean, transacted from our wallet to another wallet, like that. Metric, metric we used here. Normally they have used 3 branches compared. Here they have used 3 branches as compared to my usually 2 branches. It will transition. It is in the transition from a proof of work to proof of stake with the cash flow protocol. The Here are the nodes. In Ethereum, the nodes validate all transactions in all the new blocks, and it's operate in a peer-to-peer fashion. Each contains a copy of peer-to-peer fashion. Each contains a copy of the entire blockchain transactions, whatever. Like in here we have a light clients. They store in the headers, and it's provide very easy verification through the tree data structure. It don't execute our transactions. Use a primary for balance value. Here the Ethereum nodes are purely they don't use for the execute transactions. They are used primarily for only the balance validation. They implemented in variety of languages like Go, Rust, etc. The Ethereum nodes validate all transactions on your blocks. Normally, it operates in a peer-to-peer fashion like a Bitcoin. The accounts and wallets of Ethereum. We have 2 kinds of accounts in Ethereum. The external owned accounts, brackets like EOA are most common accounts, and the contract accounts. It consists of a public and a private key pair. Allow for interaction with the blockchain. Wallets. Here, a set of one or more external accounts used to store or transfer the coins from one account to another account by easily through wallets. External account. It has an associated account, like amount of transactions sent from the account and a balance, code hash of associated account code, a computer program for smart contract, storage root is a root hash of multiple tree of associated with accounted data. Contract account. In a contract account, Ethereum account can store and execute code. So it has an associated nouns and balance code hash, like a code hash as an associated account code storage root contains McCreary of associated storage data. Like you can see in the diagram, like external owned account. There's a nouns balance code hash and storage root. A contract account is the same. We have the nouns balance code and root, but it has a code in it because it's a contract account. So we'll see now the example account, like it's a private key. Ethereum private key generally or 66 character strings with zero expected. The case is relevant. Same derivation through ECDSA, same as a Bitcoin. For address, we have the 40 characters. Ethereum private keys map addresses directly. Simply the last 40 keys are uh, the last 40 characters of the CAC 256 hash of the public key. Addresses is a 42 character total. The total. The transactions. A request to modify the state of blockchain can run code. The Ethereum it will run code which change the global state. Contracts only balance updates in BTC. In BTC, the contracts only balance updates signed by original account types. Send Ethereum coins from one account to another account. Create smart contract. Execute smart contract mode. We can do all this in the Ethereum coin. Many concepts, concepts which are used in the Bitcoin implementation. It is used here also. Then Szabo is the next denomination named after the Nick Szabo, author of Bitcoin. It's Finlay, the second highest denomination, or name after Kyle Finlay, received from first text from Nakamoto. So you can see in the right bottom, multiplier like a name we use Java for multiplier services. Smart contracts are smart contracts. It can execute a code. It like access turning calculate functions like an external account that which holds funds can interact with each other accounts and smart accounts contains code can be called to transactions. Code execution smart contract are code execution smart contract. Every node contains a virtual machine similar to every node contains a virtual machine similar to Java. It's called the Ethereum virtual machine. Compiles code from it compiles. Ethereum the smart contract which it can compile the code from high level high level language to bit code. Ethereum smart contract code and Ethereum it smart contracts code and broadcast the states. Every full node in the blockchain process, every transaction stores the entire state. Every node in the blockchain process or every transaction, what happens, which are done in Ethereum, it stores in the entire state. It entirely stores in the state. The gas, the gas. Gas is normally gas is a halting problem. It's an infinite loop. Simply in a smart contract we have code, right? Sometimes it goes an infinite loop. So the reason for gas. Problem cannot tell whether the program whether or not a program will run infinitely from compiled. So the solution for this gas problem are we have to charge fee per computation step to limit infinite loops and stop flawed code from executing. Uh, we have to set a limit of steps which will be run free. Then afterwards we have to set a computational fee for steps. So it will stop the flawed code from executing. The user will know which is a flawed code, and then it will stop the flawed code from executing. Here in this, every transaction needs to specify an estimate of the amount of gas it will spend. Like simply, if it spent some X amount of gas on this transaction, you need to specify that I've spent this much of gas on this transaction, so it costs this much. Especially a measure of how much is a measure of how much is willing to spend on a transaction, even if buggy. Like some example, is willing to pay $10 for this transaction. So we can work how much is gas price. current gas price, normally gas price, market price of unit is in way. So this is a link you can check whether the gas price of the way is always set before a transaction by user. Normally the gas price is set before the transaction by user. So my gas limit. Normally gas limit is not, there's no gas limit like that. So it's the maximum amount of gas, how much the user is willing to pay for this transaction. So if he's willing to pay less, then the gas limit will be less and the transactions will be also less. So it helps. So this gas limit helps to regulate the load on the network. So gas cost used when sending transactions is calculated by gas limit into gas price. So all blocks will have a gas limit. So maximum gas limit for each block. So if you send a transaction from this end to this end, there will be some gas is consumed. So how much gas is consumed into gas limit? This much is the gas cost for this transaction. So now Ethereum is is in the process of moving from proof of work to proof of stake, because this approach does not require, I mean, in the proof of stake, this approach does not require large expenditures on computing and energy. Now miners are now validators. Post a deposit in the escrow account. The more escrow you post, the higher the probability you have chosen to nominate the next block. So if you nominate a block with invalid transactions, you will lose your escrow. Simply like so we have discussed in class, like if you deposit escrow, like if your all transactions are valid, then you have more chances to select. Then you have more chances to select your block next. If you have two nodes, one node is malicious, one node is honest node. So honest node will get more priority as compared to malicious node, because it always terminates. It has less escrow as compared to the honest node. That's what I'm trying to say here. One issue with this approach is that those those they have the most Ethereum will be that have the most Ethereum will be able to get even more. This leads to centralization eventually. On the other hand, it reduces the chance of 51% of attack, allows for the various transaction approvals. The protocol is called Casper, and this will be hard fork. Other approaches to conscious. There are many types of conscious algorithms like a proof of work, like a proof of work is used in Bitcoin, Ethereum, and proof of stake Ethereum in the future. Like nowadays, as we discussed before, the Ethereum is in the process from moving proof of work to proof of stakes because of some of the benefits were in the proof of stake. So POI, proof of importance, used in and like these are some PFBT, practical measure fault tolerance, and FBFT, Ferrite measure fault tolerance, DPoS, delegated proof of stake, POET, proof of elapsed time, Ethereum blockchain header, Ethereum blockchain header. Here, the block header, hash of included almost in the block header, the block header, the hash of included almost will be stored in the block header. State root is a hash of a Merkle tree that holds all account information. No, here the state root in Ethereum, the state root is a hash of the Merkle tree, is that the holds all the account information. Similarly, the storage structure for the transactions and receipt. As you can see in the block header in the right side of the screen, you can see that parent hash, nouns, timestamp, almost hash, beneficiary, log, difficult extra data, number, gas, gas. These are all stored in the block header itself. The state roots, transaction roots, receipt roots also stay in the block header. I mean, stored in the block header. Then we have the part. What is state root, transaction root, state stored in data structures known as a Merkle tree, similar to Merkle tree used in BT, but we have three lives per node. We have three lives per node. Like this is a cryptography secures a evaluation of a leaf or intermediate results in a different root hash. So you can see in the diagram, every node has a three leaves. See, for straight node, you have three leaves, and after each node, three leaves, three leaves. At last, we have in nouns, balance, codage, storage. What is state root? Each node in the state root twice represents an Ethereum address. Each address has four components like a nouns, codage, balance, and a storage root. Nouns, a list of the number of TXs from the addresses. What is nouns? It's a list of number of TXs from addresses. Codage, hash of associated code. Storage root. Mercury free root of account storage contains balance of the account. Ethereum. Normally, Ethereum is known as a difficulty bomb because it's a great spike in mining difficulty. Introduced to attempt to reduce the number of miners, aimed to pre-data shift of algorithms from proof to proof of stake. Here, Solidity. JavaScript, yeah, it is totally based on JavaScript based, most popular, not as a function as other more mature programming languages. It's a Serpent, it's a Python based language, and LL is a lib based, list based. What is Solid? Solid is a language similar to JavaScript, which allows to develop your contracts and compile the EVM by bit code. It is a it is currently the flagship language of Ethereum and the most popular. So Solidity documentation. Solidity is a flagship Ethereum high language and that is used to write contracts. Solid Normally Solidity used in a Solidity is a flagship level language that is used to write contracts. Solidity online real-time compiler. It's an online real-time compiler, Flippant. It's a language similar to Python, which can be used to develop contracts and compile to EVM bytecode. It is intended to be maximally clean and simple, combining many of the efficiency benefits of a low-level language, ease of using program style. At the same time, additional adding specific domain features for this contract programming. Serpent is comparing using triple L. Serpent is on the Ethereum wiki. Serpent EVM compilers. There's two types we have. In the smart contract programming, we have a Atom Ethereum interface. It is an Ethereum interface plugin for the Atom editor that features syntax highlighting, compiling, and runtime environment request backend node. Atom Solidity Editor plugin for the Atom editor that provides solidity linking. Mem Solidity plugin for the Mem editor providing syntax highlighting. Is the base some contract example code how the contract is made. Contract example functions. Now we have to set the value. It will be values the values value then the log incrementing. Development work. So first we have to create the account, then fund the account. Then we have to fund account, develop, compile, sign, implement. So onboard additional users, create new accounts, and develop new applications. It's a testing cycle. So now we have to create account. Programming literally Go, Python, we can use JavaScript extension. Can use like MetaMask, plus many other websites to create account. Then we have to fund account from where it's from false exchanges from club for public blockchain. Now we have to develop Ethereum application components. Base application can be developed in any language. Normally, base application smart contact connector library. Normally, base application can be developed in any language. Smart contract developed in Solidity or one of the other small contract compatible languages. Connector library facilities communication between base application smart contractors. Here now we have to sign and deploy. In the transaction state, bytes it will sign using TX and then it will be deployed using the connector. And the live smart contract is alive. Test RPC and testing. Local development or test blockchain. Thank you, sir.